Welcome to TS classes. In the last video, we have studied about the Bode plot for a constant k. In this video, we will study the Bode plot for a integral function. Integral function means in the denominator part there is a s term. So first we will study the Bode plot for a integral function. The question is g of s is equal to k by s. This is the transfer function. And the first step was to find the transfer function. And the next step was to find the g of j omega. Now put in s is equal to j omega. In place of s we have to put j omega. So g of j omega will be k divided by j omega. In the next step we have to find out its magnitude as well as angle. So first, what is the magnitude? The magnitude of g of j omega is equal to k divided by j omega magnitude. The k value is k, j omega is equal to, here the formula is omega square root over, the value will be omega. So the magnitude is equal to k by omega, and the 20 log g of j omega magnitude is equal to 20 log k by omega. This is the value of magnitude of m. We have found the magnitude. Next we will go for direction part. Theta is equal to tan inverse of the angle of k by j omega. Now what is k by j omega? Angle. For k, the angle is tan inverse of 0 by k, and for j omega, the angle is equal to tan inverse of omega by 0, because the formula for the k is equal to tan inverse of real imaginary by real. In k there is no imaginary part, so 0 will be in the upper and k will be the down level. Now in case of j omega, tan inverse of j omega by 0. Here k is equal to 0 degree, here k is equal to minus of 90 degree or minus of pi by 2 radian. Okay, so theta is equal to 0 minus 90 degree, and the value is minus 90 degree, or which is equal to minus pi by 2 radian is here. Here we have got the magnitude as well as the phase angle. Till now we have studied the magnitude is equal to 20 log k by omega base 10. Now our aim is to vary the value of omega from a minimum value towards a maximum value. The first step, if you take omega is equal to 0.1, suppose omega is equal to 0.1 k, then the value of m mod is equal to 20 log k by 0.1 k base 10. Now the value will be 20 log 1 by 0.1 base k, which is equal base 10, which is equal to, the value is 20 into 1, the value is equal to 20. Next we will put the value of omega is equal to k. So omega is equal to k, then m magnitude is equal to 20 log k by k base 10. K by k is cancelled out, so 20 log 1, that is equal to 20 log 1 base 10. We know that log 1 is equal to 0, so this value is 0 decibel. In the previous it was 20 decibel. And the next if we put the value of omega is equal to 10k, then m magnitude is equal to 20 log, in place of omega we have to put 10k, that is equal to k divided by 10k base 10 is equal to 20 into log 0.1 is equal to, then the value is equal to minus 20 decibel. Now we have got three value, 20 decibel, 0 decibel and minus 20 decibel. When the value is equal to omega is equal to 0.1 k and omega is equal to k and omega is equal to 10k. If we put this value in the magnitude plot, then we can get, this is omega, and the omega, the value is, I have taken 0.1 k. Suppose here is equal to 0.1 k, here it is k and here it is 10 k, and the corresponding values in the magnitude curve, that is m, in place of 0.1 k, the value is 20 decibels. So suppose this value is 20, now the value is here 20. when omega is equal to k, m is equal to 0. That means the point is here. And the next, when omega is equal to 10k, the m value is equal to minus 20. That means it in the here minus 20, and the graph is like this. This is the magnitude curve for when it is the g of s is equal to k by s. And the next, if we are plotting the phase angle plot, then the value is always minus 90 degree, because we have already studied by putting the any value of omega, the value is minus 90 degree. So the graph will be here like, if this is omega and this is the value of theta, then the graph will be minus 90 degree. That means by any increase in value of omega, we can get the value is minus 90 degree. Now in relation of these two plots, we can get the Bode plot for a, the question is g of s is equal to k by s. Now we will study if the value is s to the power n. That is another question we will draw when g of s is equal to k by s to the power n. Next question is g of s is equal to k by s to the power n. Here the first step is find the transfer function which is already given. Next step is we have to put in place of s is equal to j omega. So s is equal to j omega. That implies g of j omega is equal to k divided by j omega power n. S is equal to j omega is clear. Next step is we have to find its magnitude. So the magnitude is g of j omega magnitude is equal to here k divided by omega power n. So by putting it in 20 log base 10 magnitude of g of j omega, the value we can get is that 20 log base 10 k by omega power n. This is the magnitude. Next we have to go for angle part. In angle part, in the numerator the value is k and denominator the value is j omega power n. So the angle will be theta is equal to tan inverse of, in the upper k, that is 0, minus tan inverse of omega power n divided by 0. So here the answer will be 0 minus 90 degree is equal to minus 90 degree. So whatever the value of omega, the theta is always minus 90 degree. That means from this line we can easily find out that the phase angle graph will be like this. In the phase angle graph, if this is the omega and the theta is always minus 90 degree, whatever the value of omega, because the omega power n divided by 0, if something power 0 is equal to infinite, which is tan inverse of infinite is equal to minus 90 degree. So the polar plot, so the phase angle plot is always theta is equal to minus 90. So graph is like this always. This is our phase angle plot, phase plot. Now we have to draw the magnitude plot. For the magnitude plot, the magnitude is equal to 20 log k divided by omega power n. So by changing the value of omega, we can change the value of m. The magnitude in decibel is equal to m dB is equal to 20 log k by omega power n base 10. Here we have to change the value of omega from a minimum value towards a maximum value. Suppose this value first we have taken is equal to 0.1 into k to the power 1 by n. If I put omega is equal to this value, then m in dB will be 20 log base 10 k divided by 0.1 k to the power 1 by n into power is n. So its value will be 20. By cancelling out everything, we can get m dB is equal to 20 is here. This is the when omega is equal to 0.1 k power 1 by n. If I put this value k, omega is equal to k to the power 1 by n. If omega is equal to k to the power 1 by n, then m in dB will be 20 log base 10 k divided by k to the power of 1 by n, power is n. Here I can get the value that is 20 log 1 base 10, its value is 0. Similarly, by putting the value of omega, which is equal to k to the power of 10 into k to the power 1 by n, I can get m in decibel is equal to 20 log base 10 k divided by 10 k to the power 1 by n, power is n, its value will be minus 20 is here. If we plot the magnitude plot, then the graph will be in the x-axis omega, in the y-axis m. The value of omega is 3 points, that is 0.1 into k to the power 1 by n, k to the power 1 by n, and 10k into power 1 by n. So here it will be 0.1 k to the power of 1 by n. Here the value is k to the power 1 by n, and here the value is k to the power of 10k to the power 1 by n. When the omega value is 0.1 k to the power 1 by n, the value is 20 is here. It is 20 and here it is minus 20. So the first point is here, and the second point will be when k to the power 1 by n, the value is 0, and when the k value is omega is equal to k 10 into k to the power 1 by n, the value is equal to minus 20. So the graph is like this. This is the magnitude plot and this is the phase angle plot. By combination of both of this plot, we can get the Bode plot when the g of s is equal to k divided by s to the power of n. In the next class, we will study the Bode plot for the derivative functions. Thank you.